Okay, so before we actually get to the notes part of this, let's talk about numbers and our number families, okay? So we have, and we've talked about this once before, this is just our little Venn diagram of how numbers work. And this is the set of all real numbers. So real numbers, you know that we can write it as this, right? That means all real numbers? Yes? Okay, so it's that weird looking R. And then all these things fall into here. We're going to be talking about integers today. So looking at your integers, do integers include 0? Yes. How does a Venn diagram work? Everything on the inside. It includes 0. So natural numbers are your counting numbers. 1, 2, 3, 4, all positive doesn't include 0. Whole numbers are your natural numbers plus 0. Integers are positive and negative whole numbers including 0, basically. So just basically like no decimals. So what this is, and I know it's kind of hard to see, but this was the best overall example I could get. Since that R is written weird, so is the Z. It's kind of doubled like this, and that just means integers, okay? So when we use this to write something today, like we did once before with this, I want you to understand why we're doing it and what it means. I do not expect for you to, like, that's not going to be an answer on a test that you have to write and come up with. Does that make sense to you? Just want you to understand the notation and have seen it and understand why we have to do it, okay? All right, so, let's see, mine's in a little bit different order than yours is. So this is the front. This is going on page 89. This is just, all you have to do is put the ISN page on there. And let's talk about sign, okay? We're going to have parent functions, just like we did for everything else, all right? We basically created our parent functions today with the fettuccine. So our parent function, f of x, is equal to the sine of x. Our input is an angle measure. Our output is a sine value, all right? So let's think about some of the things we know about sine. What is the sine of 0? 0. Sine of 0 is 0. And when I ask you that, I still kind of expect you, like you're still picturing the unit circle, right? Where is it over here? So then what is the sine of pi? You were here, you went over here. It's 0, right? All right, so halfway between 0 and pi is pi halves. What's the sine of pi halves? 1. Halfway between pi and 2 pi is 3 pi halves. What's the sine of 3 pi halves? Negative 1. What's the sine of 2 pi? 0, right? Now, do we know what's going on between 0 and pi halves? Absolutely, right? We have a 1/2, we have a square root of 3 over 2, a square root of 2 over 2. But being a parent function, if I know the general shape, do I really need to plot those other points to understand what's happening? I really don't, do I? I mean, we did on here so we could really create what it was happening, but I don't have to plot them every single time. When I go from here to here,
Attention, Pasadena Memorial. This is your 9:30 attention announcement. Also, please be aware that enriching students seems to be down. So therefore, we are going to stay in third period. Once again, we're going to remain in third period. Thank you.
Congratulations, you're stuck with me. If you were really supposed to go somewhere for dual credit, they'll make another announcement or send, or maybe they don't want you to go anywhere, I don't know. All right, so after I get here, then it's just going to repeat, right? Just like it repeated over here. So this is one cycle of sine from 0 to 2 pi. It's like one time around the circle. Make sense? We just unrolled it. These are all our sine values that just kind of spilled out of there. So because we know it repeats, there's a pattern here, but let's just also talk about values. What's the sine of negative pi? 0. What's the sine of negative 2 pi? 0. So then what is the sine of negative pi halves? Negative 1, right? And then the sine of negative 3 pi halves is 1. Okay? So this is 2 cycles of our sine function. We good with that? Okay. So again, these are called sinusoidal functions. They are called periodic functions because they're periodic. Yeah, some other terms we'll get to a little bit later. I won't give you too much right now. All right, so what is the domain of this function? All real numbers. So that is negative infinity to infinity, right? What is our range? -1 to 1. Okay, and we include them, right, because those are actual values on our graph. All right, what about our zeros? 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, right? How many zeros am I going to have? An infinite amount, right? So I'm going to have an infinite amount of zeros because it keeps repeating. But they start at 0, then it happens at pi, then at 2 pi. So they're happening every how often? Every pi, right? Every pi units I have one. So here's what our zeros look like. It's a set of zeros because there's an infinite amount, right? And it's not a connected one, a continuous one. So it is the set of all x's such that, we've had something similar to this before, right? X is equal to n times pi. So let's just talk about that part right there. N times pi. So if n was 0, it happens at 0, right? If n was 1, it happens at 1 pi. If n is 2, it happens at 2 pi. So that's what's going to make it happen every pi units. You with me on that? But I can't have it, n can't be 1/2, right? N can't be pi even. So this is where I have to say where n is an element. So it's this weird looking e thing that means element. It's actually a Greek letter. Element of the integers. We have to say that so that we can't use partial numbers. Okay? Again, I want you to understand what that says. I want you to understand why we have to do it. I'm not going to ask you what the zeros are and expect you to write that at this point. Okay? We good on that? All right. What is my y-intercept? 0, 0. Intercept is always written as an ordered pair, right? Do I have any asymptotes? No. No asymptotes, so it's none. Okay, so then we have the amplitude. The amplitude's a new word. Let's talk about what it is. The amplitude it's the distance between, it's the distance between, there's a technical definition, but just so, for the parent function, it is the distance from the x-axis to the maximum point, okay? It's actually half the distance between the maximum and minimum, but so this is my amplitude. How far above the x-axis am I going when it's the parent function, because I don't have any other shifts or anything. So my amplitude for your basic just parent function is just 1. Amplitude is where our a is going to come from when we have transformations, and we'll go from there, okay? Then the period is how long does it take for one cycle of sine to happen? And you can actually start anywhere. If I started here, and I would go from -pi to pi, that's one cycle before it repeats, right? So that's a distance of 2 pi. Now it's easier to start here and say, all right, go from here to 2 pi, but you can really start anywhere. One cycle from wherever you start for the parent function is going to be 2 pi. Okay. All right, so let's write down what our transformations look like for this. F of x is equal to a times the sine of b times x minus c plus d. So let's talk about transformations from what we understand. You've been doing transformations for years. We've done them multiple times this year already. A represents your what? Vertical stretch or compression, right? Vertical stretch or compression. Your B is your horizontal stretch or compression, right? C is your horizontal shift. D is your vertical shift, right? All those things are still exactly the same, just with trig functions, some of them have different names, but they're still doing the same thing, okay? And we also have little ways to find them. So your amplitude here, just like your amplitude is how tall it is, kind of. I mean, again, we'll get a little bit more specific with that. But how far we're going to stretch it, your amplitude is like your vertical stretch, so it's the absolute value of A. And it's the absolute value because the negative would be a reflection, right? Those still happen as well. Okay, so your period is how long it takes to complete one. This is just one cycle. Okay, so the period is just one cycle. You find that by doing the period is equal to 2 pi divided by the absolute value of b. Because 2 pi is one period, and we're dividing it by and again, it's the absolute value because the negative would denote a reflection, and so it gives you that, okay? So if b was 2, if this was 2 right here, then that would be a horizontal compression, right? It would squish it by 1/2. Well, look what happens here. We'd have 2 pi divided by 2, so our period would now be pi, which means it gets squished because I have to finish the cycle in pi units instead of 2 pi units. So it's the same thing that you're doing. We just have to use 2 pi because it's a trig thing with radians, okay? Then your frequency is directly related to this. Your frequency is the absolute value of b. Now, sometimes you're not given an equation. Sometimes you might be given other things, so we need to know how to figure this out. The absolute value of b is equal to 2 pi divided by the period. See how these are basically the same thing? So the frequency tells you how many cycles happen within 2 pi. That's what you're looking for. So sometimes you're asked for the frequency, sometimes you need the period. It depends on whether you're writing the equation or you have the equation you want to graph. You know, different things work out different ways. Okay? We all good with that? All right, so your horizontal shift is called a phase shift. It's still a horizontal shift, but it, again, has a different name for phase shift. So that is still just C, just like it's been. So it's maybe called a phase shift, and that's all it says. Doesn't say anything about horizontal. It's the same thing. Vertical shift, still called vertical shift, and it's just D. Okay. So your midline is going to be a hugely important part of you being able to graph these. The midline is what it sounds like. It's the horizontal line that we use kind of like we use for an asymptote. It's not an asymptote, but my midline right here would be the x-axis because it's literally the middle of the graph vertically. You with me on that? So the amplitude is the distance from the midline to the maximum point or to the minimum point. So your midline is just whatever your vertical shift is. So it's just y equals d. And it is a line, so it's y equals. Just like with your asymptotes, they were lines. We had to write it that way. Okay, we good? All right. So I know technically class is supposed to be over, but let's go ahead and get through cosine because then we'll be done with this, and then that'll give you time to work today and even more time to work tomorrow. Okay, so we're going to go ahead and get through cosine. All right, so cosine. Your parent function is f of x equals the cosine of x. So what is the cosine of 0? 1. Right? What is the cosine of pi? So cosine of pi, -1. Halfway between 0 and pi is pi halves. What's the cosine of pi halves? 0. What's the cosine of 2 pi? 1. What's the halfway between pi and 2 pi is 3 pi halves. What's the cosine of 3 pi halves? 0. Okay. So understanding what the curve looks like, do we really need to plot any more points? No. Okay, because we just have this, we don't connect the dots like V's and stuff, but it looks like this. All right, I'm going to continue on. So then, what is the cosine of negative pi? -1. Cosine of negative 2 pi? 1. Cosine of negative pi halves? 0. And the cosine of negative 3 pi halves is 0. So this is actually 2 cycles of cosine. Okay? That was your first one, and then continues on in both directions there. But I wanted to make sure you understood how it just keeps on repeating. Everybody okay with that? So what's the domain here? Negative infinity to infinity again? What's the range? -1 to 1. Okay, back to this weird zeros thing, right? I don't have a 0 at 0. My first 0 happens at pi halves, right? And then it happens every how many units? Every pi. So this is pi halves, so it's still happening every pi units, but I don't start at pi. You with me on that? So if I'm going to start off and say, okay, my zeros are the set of all x's such that x equals. I know it's happening every pi units, so my rate of change is pi, so it's n times pi. The problem is there, if I put in 0, I get 0, and I don't want that, so I have to add pi halves to it, because then 0 plus pi halves starts me at pi halves, and then it's going to happen every pi. Does that make sense to you? And then I still have to say where n is an element of the integers. Right. Now it looks all weird, but seeing the, pretty much the same thing. We just had to shift it over, right? Just like over there, what did I have to do? I had to shift cosine over, right, to make it look like sine. All right, what is my y-intercept? 0, -1. Good. Do I have any asymptotes? No. What do you think my amplitude is? 1. Okay, it's the distance from the midline to the maximum. And then I complete one cycle. So this is my start here. When I come back here, then I'd start repeating, so it's still 2 pi. The period is 2 pi. Oh, it's 0, 1. Thank you. I'm sorry. I think that's even what y'all said, and I was like, yeah, 0, -1. Period is still 2 pi. Thank you. Everybody good so far? Okay. So then my transformations look like this. F of x is equal to a times the cosine of b times x minus c plus d. Now we don't do all the transformations every single time, but that's where all of them are just kind of plopped in there. Okay. And notice here that this b has to be factored out of this for these to work. Okay? Carolina, you with us? So your amplitude, where do we get the amplitude from on here? A. Okay. So your period, oh, it's the absolute value of A, right? Your period, which still again is just one cycle, period, it's just, you find it the same way. It's 2 pi divided by the absolute value of B. Okay. Your frequency is the absolute value of B. So last time when I said, okay, so like if this was 2, then I'd have a horizontal compression of 1/2, right, which truly is what's happening, but then my period would be pi. My frequency would be 2, which means that 2 cycles happen within that 2 pi. All right, so absolute value of B is equal to 2 pi divided by the period. Okay. Your phase shift is your horizontal shift that you've known forever. That's just C. Vertical shift is still D. Your midline shifts along with it. It is a line, the keyword line, so it is y equals D. Okay. What questions do you have? All right.